Hey guys, we are going to look at tree diagrams and something called the fundamental counting principle. Okay, so there are 2 types of bread, wheat and pita, 4 types of meat, turkey, chicken, steak, and ham, and 3 types of drinks, water, lemonade, and tea. They want to know how many possible outcomes are there. So basically, how many combinations can I come up with for the meal that I'm trying to make here? A tree diagram just kind of helps you show all of the options. It gives you a nice visual of all the different possible combinations you could make. So that is where we're going to start. So these can either kind of go downwards or they can go across. It's really up to you and like how you like to keep it organized. This has 3 different things we're choosing, right? The bread, the meat, and the drink. So it's going to have to go out a little bit. So I'm going to, I think, do mine downwards. Okay. And the first thing I'm choosing is my bread type. So either wheat or pita. I don't really want to write those words. So I'm just going to shorten these down to like the first letter. So my first option is wheat or pita. Okay. Once I've decided on my bread, then I have 4 different meat options. So let's say if we chose wheat, we could choose then turkey, chicken, steak, or ham. I would try to keep those kind of spaced out like this because we're going to have another branch come off of that when we go to do our drinks. Okay. Again, notice these branches. That's why it's called a tree diagram. So that's what it looks like on the wheat side. But if I chose pita instead, I still have those choices. So I could choose turkey, chicken, steak, or ham. Okay, I'm going to switch colors just so I can see it a little better. So finally, I get to choose my drink. There's 3 different drink types: water, lemonade, and tea. So if I went with a wheat with turkey, I could choose then water, lemonade, or tea. If I did wheat and chicken, I still can choose water, lemonade, tea. For steak, I still have those 3 options: water, lemonade, tea. Ham, I have my 3 drink options: water, lemonade, tea. Okay, on the pita side, same thing. So for turkey, I can do water, lemonade, tea. For chicken, I can do water, lemonade, tea. Steak, I can do water, lemonade, tea. And ham, I can do water, lemonade, or tea. Okay, so that's kind of what the tree diagram looks like. You can see all the possible combinations. Like you could have a wheat sandwich with steak on it and have water to drink. Or you could have pita with chicken and lemonade to drink, right? So it's showing you all the different options that you could choose, how you could make your sandwich and choose your drink. To actually answer the question, how many possible outcomes there are, we go back to that very final row, so the green row that I did, and we just count up just that final thing. You don't have to sit here and count each branch out necessarily. You can, but even easier is I can just count these. So like 1, 2, 3, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 outcomes, 24 different combinations that I could make with these options. Okay, that is a little time consuming. It's a nice visual, but sometimes I don't want to have to do all that work. So I'm going to show you a little shortcut. It's called the fundamental counting principle. Basically what I do is I just check out what all my different options are. So like first of all with my breads, how many options were there? There were 2. Okay, then how many options for meat were there? Well, there were 4. And how many options for drinks? There were 3. So I just think about all the different categories, how many options were there in each category, and then, watch this magic, all I have to do is multiply them. So 2 times 4 is 8, 8 times 3 is 24 outcomes. We get the same answer either way. That is way quicker, obviously. But sometimes the visual is nice. Sometimes I'm going to ask you specifically to give me a tree diagram. I want to see that you know how to make the picture. But if I don't ask you specifically for a tree diagram, there you don't have to do it at all. Okay, you can use the fundamental counting principle. Just be careful, make sure you know what your numbers are. Multiply them properly. We can use calculators, so use those resources. Okay, all right, let's go ahead and do another one. So here we go. A restaurant offers a fixed price Valentine's Day dinner menu for $40. The dinner consists of 3 courses and a diner chooses one item for each course. So how many different meals are possible? If you want to draw a tree diagram, you're welcome to. I do not want to. So I'm just going to look. In the first course, I have 3 options. For my second course, I have 5 options. And for my third course, I have 2 options. So all I have to do for my fundamental counting principle is do the 3 times 5 times 2. 3 times 5 is 15 times 2 is 30 different meals. And that's it. Easy. Okay. Again, I could have drawn a tree diagram, but look, we would have had to end up with 30 branches down at the end, and that just sounds like a lot of work. All right, here's another one. So Miss McCall is going to Boston Market. She gets to choose a meat, either turkey, chicken, or ham, 2 of the 8 sides, and a dessert, chocolate cake or cheesecake. All right, so let's see here. Again, I could totally make a tree diagram. That sounds awful. So let's see. For my meats, I have 3 options of meats. I get to pick 2 sides. I have 8 choices of sides. So for my first side, right here, let's label this a little bit. This is for my meat, just so we can all stay together here. This is for side number 1. Okay, for my side number 1, I have 8 choices because there are 8 different sides I can choose from. I get to pick 2 sides though, right? So I'm going to have side number 2. And how many choices do I have? I really still have 8. I could get double mac and cheese. That sounds delicious. Okay, and then I still also have my dessert, which I had 2 choices, chocolate cake or cheesecake. So times 2. All right, so we've got 3 choices for meat, 8 for the first side, 8 for the second side, and 2 for the dessert. Go ahead and use your calculator and find what this is, and we'll see if we get the same thing. All right, when I multiplied that, I got 384 options. Thank goodness we did not make a tree diagram for that. That really would have been just awful. So this fundamental counting principle is super helpful. All right, we got just a couple more. Okay, so a cafe features ice cream cones in 24 flavors and 6 toppings. You can order regular, sugar, or waffle cones. So how many possible ice cream cones can you order if you have 1 cone, 2 scoops of ice cream, and 1 topping? And I gave you a little hint. It says you can get 2 of the same flavor. Okay, so let's step this out again. So first thing I have to choose is my cone. Okay, and then I will, let's see. So how many cones are there? There's a regular, sugar, and waffle. So there's 3 different options for cones. Then I'm getting 2 scoops. So this is for scoop number 1. And it says there's 24 flavors. So I have 24 options. And then I have a second scoop. So for scoop number 2, there's still 24 options because it says I can get the same flavor. Maybe you want double strawberry or whatever. So still 24. And then I'm getting 1 topping. So topping. And let's see. 24 flavors and 6 toppings. Sorry, I had to find that up at the top. So there are 6 different toppings. Go ahead and use your calculator and let's see what you get. Okay, so when I did this, I got 10,368 different possible combinations. I'm just going to say options. That is a lot of different options that you can get at an ice cream store. Okay, so I know this looks like the same question, but let's read it. A cafe features ice cream cones and 24 flavors and 6 toppings. You can order regular sugar and waffle cone. How many possible ice cream cones can you order if it had 1 cone, 2 different flavored scoops of ice cream, and 1 topping? So I just changed that one little piece of the question, and let's see what difference it makes. So again, we're starting with the cone. We have 3 options for that. And then we have scoop number 1, which there are 24 options. Okay. Then I have scoop number 2. So here's where it changes a little bit. If I'm trying to get 2 different flavors, there's 24 to start with. Once I choose that first one, now there's not 24 options anymore. There's only 23 because I'm trying not to duplicate it, right? I don't want to get the same flavor twice. So instead of 24, I'm down to only 23 options there. And then finally for our toppings, there were 6 options. Okay, go ahead and solve that and come back to me. So when I solved this, I got 9,936 options. So notice that really did change how many possibilities we had. We were over 10,000 before, now we're under 10,000. Okay, we just have one more. How many different 2-digit numbers are there? This one is super tricky every year. So let's see. If I'm talking about a 2-digit number, well then I have like the tens place, right? So here's my tens and I have my ones. So how many options are there that I could possibly put into the tens place? Right, well I have my 10s, my 20s, my 30s, my 40s, 50s, 60s, 70s, 80s, and 90s. So 1, 2, 3, 4, 5, 6, 7, 8, 9 options for my tens place. Then my ones place. Okay, so for my ones place, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options for my ones place. And then 9 times 10 is 90. There are 90 2-digit numbers. Think about it, right? If we're really going like 10 through 99, if you counted those up, you would get 90 of them. We don't want to count them up. We want to just use our fundamental counting principle. So this is how you do that. All right, so I am all done. You've got a couple more I want you to try. Make sure you read the instructions. Some of them do ask you to draw a tree diagram, and then others don't say that. So if it doesn't say, I would just say do the fundamental counting principle. It's going to be so much easier and so much faster. Make sure you show your work, and that's it. Thanks, guys.